Hi everyone. So in this video we're going to look at how to find an equation of a given curve if you have been given a gradient function and a point. So we have a question here which says we have been given a gradient function, we've been given a point, and firstly you are being asked to find the general solution of the differential equation, and then we are also asked to find the equation of the curve with the gradient function and the point, and lastly we are asked to find if a certain point lies on the curve. So let's get into it. Part A, we need to find the general solution of the differential equation. So I've been given dy dx is equal to 6x squared plus 5. So this is the same as saying dy is equal to, open brackets, 6x squared plus 5, close brackets, multiplied by dx. This dx just goes on the other side. We're sort of like we are actually cross multiplying. Okay, so the idea is we want to integrate the given equation. So we introduce the integral signs on both sides so that we can remain with y. Y will be equal to, so remember that integration is the opposite of differentiation. When you're differentiating, you reduce the power by 1 and then you drop the power and multiply it with this term. So we need to do the reverse when doing integration. So this means that here we'll have 6 over 3, because when we add 1 to this power it will give us 3, and then we have x power 3 plus 5x plus c. This is the same as saying 2x power 3 plus 5x plus c. So this is what y equals to, or this is what the general solution of the differential equation is. Part B of the question says find the equation of the curve. Allow me to rub this off. Let me just copy this. Y is equal to 2x power 3 plus 5x plus c. Okay. So part B, we are asked to find the equation of the curve with the gradient function dy dx, and which is passing through that point. So what that means is that we are just going to use this same equation that we have and input the values of x and y, and then find the value of c. So the point that has been given is 1, 9, meaning that where there is x we'll put 1 and where there is y we'll put 9. So let's go on, let's proceed and do that. So where there is y we are going to put 9. This is equal to 2 multiplied by Where there is 1, where there is x, we'll put 1 power 3 plus 5 multiplied by 1 plus c. So 9 is equal to 2, because 1 power 3 is 1, plus 5 times 1 is 5, plus c. So 9 is equal to 7 plus c. C is equal to 9 minus 7. C is equal to 2. It means, therefore, that the equation that is required is going to be y is equal to 2x power 3 plus 5x plus 2. That will be the equation of the curve. Lastly, we are required to show that this point -1, -5 also lies on the curve. Okay, allow me to rub again so that we can have some space. Okay, so if this point lies on the curve, it means that when we input these values into the equation is going to be satisfied. Okay, let me demonstrate what I mean. So we have an equation, y is equal to 2x power 3 plus 5x plus 2. So where there is x, we'll put -1, and where there is y, we'll put -5. So -5 is equal to 2 multiplied by -1 power 3 plus 5 multiplied by -1 plus 2. This is equal to minus 2 minus 5 plus 2. So this 2 and that 2 will cancel, and we're going to have -5 is equal to -5. So this means that this point lies on the curve, because the left hand side of the equation is the same as the right side of the equation, so the equation has been satisfied by that point. So therefore point -1, -5 lies on the curve. So that's how you handle such questions. Alright, thanks. See you in the next video.